Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to for the chapter that is coordination compound, that is for class 12th, and it is according to CBSE syllabus. Now here part C, 4 part C, here the terms related. What are the terms related now? Coordination number, coordination sphere and coordination polyhedra. And here what is coordination number? You know what is ligand? Ligand should contain a donor atom. Ligand may be unidentate, that means one donor atom, and didentate, two donor atom, polydentate, so many donor atoms. So here from ligand, how many donor atom present? From that we can calculate coordination number. That means coordination number means the number of ligand donor atoms. How many donor atoms present in a ligand, and total how many ligands are present? From that you will calculate that coordination number. That means number of ligands having donor atoms attached to central atom or ion. Then how? Example, suppose unidentate ligand is present. Suppose in a coordination compound unidentate ligand present. What is unidentate? Ligand having one donor atom. One donor atom, only one. That means here what happened? Here only one donor atom present, and just like example, this is chloride ion. I told ligands are negative ions or molecules. Negative ions or molecules or both. That means chloride ion is a negative one, and 6 chloride ion present, and which are attached to platinum by the coordination bond. So what happens here? 6 chloride ions are attached to platinum, and that is why here the coordination number is 6. How? Because chloride is a monodentate ligand having one donor atom. Since one donor atom and 6 ligands mean 6 donor atoms. 6 donor atom mean the coordination number is 6. And similarly here nickel ammonia, here ammonia, that is 4 times a nickel, and total charge is +2. How you will give name this one? Later we will see nomenclature, but only remember inside the square bracket what is present? The nickel is the metal atom present, and that ammonia is the molecule, ligand neutral molecule is present. So what happens here? The 4 ammonia molecule present inside the square bracket, and which are attached to nickel atom. Is attached to nickel atom, that means here the coordination number is 4. Why? Because ammonia is a unidentate. That means one donor atom present. Then how many donor atom? 4 donor atom present. So its coordination number is 4. Why? Because 4 ammonia molecules are attached. Now next is this one. Inside this square bracket, what is the metal present? Fe, iron. And what are the ligand present? What type of ligand present? C2O4. What is C2O4? Oxalate. Now in this oxalate, what is the charge? -2. So that means it is a didentate ligand. Then one oxalate ion can give 2 donor atoms, can donate 2 atoms towards the central metal atom. That means how many donor atom present in a oxalate ion? That means here 2. That here what happened? How many total ligand present? 3. One oxalate ion having 2 donor atoms, that means 3 oxalate ion having 6 donor atoms. Coordination number regards to the how many donor atoms are there. Total donor atoms 6. So coordination number is 6. Inside the square bracket, cobalt is there, and En3. What is En3? En is called ethylene diamine. That is also one ligand. And what is that one? Didentate ligand. So how many ethylene diamine is there? 3. 3 into 2, 6. That means 6 donor atoms present in this structure, in this compound. That is why the coordination number is 6. Again see, coordination number, how will know? The number of the donor atoms present in the ligand. If one ligand having 2 donor atoms, then how many ligands are there in the coordination sphere? You will check it. If unidentate, that means 1 donor atom. Suppose here in the case potassium is outer side, PtCl6. That means here what happened here? 6 chloride ions are attached to platinum, and it is called 6 chloride ligands present. That is why what is coordination number 6. Here 4 ammonia molecules, so it is coordination number is 4. And here oxalate ion, that is didentate ligand. One didentate ligand can, that mean having 2 donor atoms. So 3 didentate ligand, that is oxalate, that is 3 into 2 6 donor atoms. That is why the coordination number is 6. And here what you will observe, coordination number is 6, that means 6 bonds are present. And now you can see these are sigma bonds. Before that it is regarded as coordination bond, now it is sigma bond. And now how many sigma bonds are there? 6 sigma bonds. How many sigma bonds there? 4 sigma bonds. 4 means coordination number 4, 6 means coordination number 6. Then you will see what is coordination sphere. This is called actually coordination sphere. What are present in coordination sphere? One metal and the number of ligands and having charge. How can you calculate the charge? How can you name it? Nomenclature you will see later, but you should know what is coordination sphere. Now I am going to tell about the coordination sphere. Coordination sphere. What is meant by coordination sphere? Sphere means area. That means here what happened, the area that is in square bracket, you have seen also in square bracket metal atom and ligands are present. Metal atom or ions with ligand, that means ligands bound to or attached to central metal atom or ion. That is called coordination sphere. Very easy. In square bracket area what is present? One is metal atom or ion present, and second is that is ligands present. Ligands may be anion or molecule, or may be both anion and molecule. And you can see from that what is coordination number also. What is counter ion? Within square bracket what is present? That is complex ion, and inside square bracket the area is called coordination sphere. And outer side coordination sphere what is present in the form of ions, that is called counter ion. You can see here, this is one example where K4 and whole square bracket FeCN6 Cn whole 6. See again, K4 then square bracket here FeCN whole 6. What it indicates? It indicates cyanide is a ligand, and that is unidentate ligand. And how many ligands present? 6 ligands present. Okay. And now how this charge comes to -4, and these things you will clear in nomenclature. Only remember the charge is -4, or you can see if you know better, then Cn -1 into 6 -6. If it is -6, the total should be how much? Here this should be +4, sorry, this is Cn6, Cn -6, this is +2, that is why it is -4. See again, Cn -6, or you can write here also, I can show you -6, it is +2, so total charge is -4. Since it is -4, this should be K4. And so here outside the bracket what is present, that is called counter ion. K plus is counter ion. FeCN whole 6, the charge is -4, is called coordination sphere. Again see, FeCN whole 6 within the square bracket having charge -4, that is called coordination sphere. Next is this example, this is cobalt and NH3 whole 6, that is in the square bracket, charge is +3 and outer side square bracket Cl3, and this is called counter ion. Cl3, how many Cl? 3 Cl, that is 3 Cl minus, because it is charge is -1, so it is +3, it should be -3. So what you say? 3 Cl minus is counter ion, and inside the square bracket that is coordination sphere. Now here what is coordination sphere? Cobalt, square bracket start, cobalt, and then NH3 whole 6, square bracket close, charge is +3, that is coordination sphere. Similarly, next example, copper. square bracket starts copper NH3 whole 4 and the square bracket close having charge +2 and outside the square bracket what is present? SO4 minus 2. This SO4 minus 2, that is sulfate ion. Actually in inorganic chemistry you can see this is sulfate ion. It can give the taste of sulfate also. That means here it is called counter ion because it is present outer side the bracket. Now next what is remain inside the square bracket? CuNH3 whole 4 having charge +2, that is called coordination sphere. I hope it is clear. Again see what is present in square bracket. One is metal atom or ion and that is attached to ligands are attached to square bracket ligands are attached to central metal ion or atom and within the square bracket area and having some charge either plus or minus. E plus that is called complex cation, if minus that is called complex anion, if 0 that is called neutral complex. Are you clear? See again, this is efficiency whole 6 that is called coordination sphere within square bracket and this is K4, K plus ion, that is the counter ion, and this counter and part gives acid radical basic radical test. The counterpart ions either if plus then basic radical, if minus acid radical test it will give. So next we will see what is coordination polyhedra. Coordination polyhedron. What is meant by coordination polyhedron? That means it is having geometrical shape. What is geometrical? Why the geometrical shape? The question arises because the ligands are attached to central metal atom or ion in a spatial arrangement, in a space arrangement. That means metal atom in the middle and ligands, that is either molecule or anion, that is attached that are attached to the central metal atom or ion in spatial arrangement, that means in space arrangement. That is why it can produce geometrical shape and that is called polyhedron. And now geometry of the molecule, that means any coordination compound which is formed by the help of ligands and metal atom or ion in a coordination sphere having charge, they should have geometrical shape because only possible the arrangement of ligands outside the towards the central metal having spatial arrangement, and so it should be any type of geometrical shape. It depends on the coordination number. Coordination number means the number of ligands. Number of ligand means the number of donor atoms. How many total donor atoms are there? How many ligands are there? What is the type of ligands there? And according to that, also it depends on hybridization. That means it depends on hybridization. Later we will see what is the hybridization in coordination compound. Depending on the hybridization, depending on the type of ligands, depending on the how many total donor atoms, that is coordination number, all the things we will see, and after that geometrical shape can be calculated. But now you should remember there are how many geometrical shape? Octahedral, tetrahedral and square planar. How many? Octahedral, tetrahedral and square planar. Coordination number if 6, surely you will get octahedral shape. What is the octahedral shape? See, this is the 1, 2, 3, 4, 5, 6. 6 ligands are attached, so it is octahedral shape. Are you clear? Octahedral shape means it just like this one, and of the above one ligand and now below one ligand, and here 1, 1, 2, 3, 4, 5, 6. Totally 6 ligand. So octahedral shape should be octahedral. If coordination number is 4, there are 2 chances. It depends on the hybridization. And here tetrahedral shape, then this is the coordination number 4. If also square planar, if the coordination number 4. Only you remember the hybridization, whatever hybridization here, and after that you can say what is the type of structure. And here this is called tetrahedral shape, and the example is NiCO whole 4. Tetracarbonyl, nickel tetracarbonyl, which is neutral complex. Here the charge is 0. Here you can see octahedral example, cobalt NH3 whole 6. That means here having charge plus 3. This is cationic complex. This is neutral complex. Then square planar. If it is square planar, this is the structure. 1, 2, 3, 4. 4 ligands attached. Here also depending on the hybridization, the structure is there. And here example PtCl4 to the power the square bracket, above that -2 charge. Since it is -2 charge, this is complex anionic complex. Here cationic complex, here neutral complex. So this is the square planar. Now remember, like this square planar, this one, and tetrahedral structure, this one, octahedral structure, this one. But when you will read hybridization, at the time how the structure is formed, what is the geometrical shape possible, it is clear. It will clear. Other geometrical shape also there. Trigonal bipyramidal, triangle shape, bipyramid, one above, one below. See, triangle shape, one above, one below. Then what is that one? 1, 2, 3, 4, 5. And similarly square bipyramidal means 1, 2, 3, 4 and it is 5. In square shape there is a bipyramidal. In triangle shape there is a bipyramidal on above one ligand and below that one ligand. Now I hope it is clear. Coordination polyhedron is geometrical shape that is arise due to hybridization, but only you will remember now spatial arrangement which gives the polyhedron and that having geometrical shape. There are how many? Octahedral, tetrahedral, square planar. After that also other structure trigonal bipyramidal and one is square bipyramidal. And examples I have given here, CONH3 whole 6, coordination number 6. So surely it is octahedral, but if the coordination of 4, there are two charts. One is tetrahedral, other one is square planar. Then what to do? If you remember, you should remember what is the hybridization here. In tetrahedral means sp3 hybridization should be there, and here dsp2 hybridization is there. That is why according to hybridization you should remember when you will read hybridization in coordination compound. I hope it will clear. Similar other structures possible, trigonal bipyramidal and square bipyramidal. I hope this chapter up to here it is clear to you, and hope you will subscribe my channel B.L.DASH short and sweet in chemistry, and also please like and share my channel. In coming video what is oxidation number, homoleptic and heteroleptic, these all the terms I will clear this one, and only limit points are there. Coordination number, heteroleptic and homoleptic are there. So